Hi everyone. So today we would be starting with the next video, and this would be a new series on basically that would be focused on large language models. So you must be thinking why I haven't uploaded any videos since past 2 to 3 months. So actually placement season is going on in my university and I'm busy with that. But I will make sure to post videos regularly from now onwards till at least till next to 2 to 3 months till we cover all the things that I have in my mind regarding large language models like BERT, T5 and many others. So in this one, let's talk about a very simple model that is Flan T5. Now for people who actually don't know how to use Hugging Face, I will make a separate video regarding this that would be out in next 2 to 3 days, like explaining what is Hugging Face and how you can use it. So cool. So let's start with some basics. What I'm going to use in this video, I'm going to use transformers library. I'm going to use the dataset library, library from Hugging Face. I'm going to use PyTorch. Yes, PyTorch, and then I'm going to use torch data. Now, your question regarding these libraries would be that why are we using Torch and not TensorFlow? So I know that most of the videos, I think even not most, 95% of the videos in which I have used ML applications in my YouTube channel is using TensorFlow. But the reason I'm using Torch here is to make things easier. See, you can do the same thing in TensorFlow too, and I will make sure to give you the guidance how you can do that at the end. And according to your responses, if you want, I will make the future videos in TensorFlow only. But for the sake of this video, we will use Torch. Cool. So first thing that we are going to do in this video is export all the libraries that we actually need. So I'm just simply going to run this, and we are going to get transformers, datasets, torch and torch data. So to all the people who don't know about transformers, I have taught about transformers in one of my previous videos. I will give you the link to that video in the comment section. So the reason I am using transformer here is because the whole concept of large language models depends on transformers. Now just think like that. We are taking some input, then we are encoding it, and then we are pre-processing all the data, and then we are decoding it. This is how a transformer works in a 2 to 3 line way. If you want to go in deep, I would give you a research paper named "Attention is All You Need." That is the first research paper where we are introduced to a concept known as transformer. Like, transformer has been existing from before, but the core concept of transformer, of attention, multi-attention, everything has started from there. I will give you the link to that, and I will try in the next like 8 to 9 days to like decode that whole research paper. Most of the famous YouTubers who have done research on machine learning and deep learning have already done work related to like decoding that famous research paper, "Attention is All You Need." But okay, in simplifying words, I will try to do that. Cool. So what are we going to do in this particular video? We are going to use a particular already existing transformer. We are not going to build any transformer from scratch, so that things are easier here and you get to know how exactly a transformer works. And what we are going to do, this is a dataset that we have named dialog. So this dataset has like ID, and that we have dialog, then we have summary, and then we have some topic. Okay, so in this bit dataset, basically you have one dialog between 2 to 3%, then you have summary of that particular dialog, and then you have the topic of that dialog. So what do we want? We want to create a model, like fine-tune a model in which we provide the model with some of the dialogue between, like a conversation between me and my friend, and that transformer or that large language model is able to give the summary of that particular conversation that I had with my friend in uh, is in as much load time as possible. Okay, so okay, cool. From datasets we are going to import load datasets. From transformers we will import auto model for sequence to sequence large language model. Then we have auto tokenizer, then we have generation config. If you guys don't know about these terms, not a problem. As we will use it, you will get to know about it. So I will simply run this, and then we have numpy and pandas as usual. Okay, so now in as you saw above, we imported pip.install datasets. Now here we are going to load a dataset. So this is the dataset name. Here you go, and then you have everything. So I would simply just load it. Okay, we are loading the dialogues from dataset. Now let's visualize it. Like, how does it actually look like? So we actually already have a dataset viewer in Hugging Face. You can actually see it here. But let's, for the sake of this video, we will look at it here. You have this example, like test ID 1, the input dialog, what time it is Tom, they are talking about everything, and then you have a baseline human summary. Okay, the reason I've written that, you could have even written anything you want according to your things. Then you have topic, that is transportation, then you have another example, then you have the baseline human summary. So yeah, it's working fine. We have loaded the dataset successfully. Now let's load the Flan T5 model. Let's talk about it in detail. Okay, so there are a lot of models, just go here, and if I go here, if I tell you the like models, they are text, these are the text models that we have, and inside which we have Flan T5. See, if you go here, you will see a lot of things that you already know. This is the famous bird model by Google. Then if you go below, I think we will find GPT. Here is GPT. So you have got a lot of models here. Do we have Llama here? The latest model by Facebook. I think that is not available in public right now. Cool. Okay, fine. We will go to Flan T5. So okay, this was released in this particular research paper. You can go and read it if you want. I won't do it right now because it would take more than 30 to 40 minutes to explain this. Its name is Scaling Instructional Fine-Tuned Language Models. Okay, so it is an enhanced version of a T5 model that has been fine-tuned in a mixture of tasks. So one can directly use the Flan T5 weights without fine-tuning it. So these are the improvements. If you want to see the other variants, see, every model has a lot of variants, and in this model also we have a base variant, we have a small variant. Suppose you don't have that much computation power, in that case you can simply go and use Flan T5 small. You can see the whole architecture here, how it is working here. Okay, now if I go here and simply like do this and do that simply for Flan T5. Okay, cool. So this is going to explain me everything. Okay, fine, we don't have that, but we have that for Flan T5 model. So you can do everything here, table of content, everything is available here. Cool. So now you must be thinking, how do we actually use that here? So there is a lot of ways actually you can use it. Simply you can go and from model, just use from pre-trained, because we are actually importing it from the already existing one. And for Tokenizer, we are going to use this. Now if you guys don't know about what is Tokenizer, everything, I would recommend you to go and watch my natural learning processing series. That will make things easier for you. Cool. So we are done with, we have imported the model, we have imported the model here with the model name. Then we have done the same for Tokenizer. So for performing and like encoding and decoding, we need to work with the text in tokenized form. So tokenization is the process in which the operating system actually splits the text into smaller units that can then be processed by large language models. So we have downloaded that. So till now the notebook starts with the installation of the transformers library, which provides tools for working with models like BERT T5. And till now we are loading the datasets. Necessary datasets and tools are imported, such as load dataset, and then we have a dataset name, we have downloaded that, we have visualized it, and some specific indices are selected for visualizing that part. So there is an explanation about tokenization. As I told you, we have to convert text into format that is suitable for large language models. Now coming to encoding and decoding. So an example for this is like what time it is, Tom. So it is provided for this demonstration purpose only. You don't need to consider that as an example from dataset. So we are going to encode it using this tokenizer, then we are going to decode it. Cool. So let's do this. Okay, so it is already present in the tensor format, as you can see here. But suppose if there was a different sentence, then what would have happened? That's the case, I want you to go to this notebook and play with this. So let me just copy this whole thing and just go here, and let's simply copy it. Cool. And we can paste it. Now instead of this, I could have written anything. I could have written what time is it, or let's say my name is Harry. This would have produced something different result, because we are encoding it, because obviously it won't be same like this, it's a different sentence. So yeah, you can do that. Now we are going to do prompt engineering. Now if you guys don't know about prompt, I would very highly recommend you to go and just for once consider all the parts when it comes to GPT models. So in GPT model there are several things that are present there. So prompt is one of the things in which you actually give the input to the GPT model and then it acts accordingly. Okay, so Same thing we are doing here. Using previously selected indices, we are going to prompts are engineered for the model. So the exact details of this process are not clear from the overview that you are seeing here. So but we will dive later in this part. So we are going to take index, then we are going to take dialog, summary, inputs, output, and everything. If you guys know about LangChain, using LangChain we can actually do this whole prompt in thing very easily. But don't worry, in the next maybe after 2 to 3 videos we can use LangChain here, and I will tell you how we can make things like this easier here. For now, the input prompt is this. Okay, these are the input prompt. This is the baseline summary and everything. So you are basically giving the model like this. Okay, GPT, think like this. This is the input type. This is the expectations of my part. Now generate something for me. So something like that. Okay. Now we are going to do a zero shot interference. Now if you guys don't know about it, I will very highly recommend you to go here and just see about it. Zero shot text classification and everything. What is exactly zero shot classification? It's a very good article, and still if you guys don't get it, this is a very beautiful article that has been written by Paulomi Chatterjee, that is available on the Analytics India mag, and it tells you actually the difference between zero shot, one shot, and few shot learning difference. Cool. So what once you are done with that, we are going to perform the input constructed prompt instead of the dialog. We are going to take the input using Tokenizer, then we have the output from it, and using the notebook of this part in this phase particular demonstrates how we are going to perform the zero pot, like this is the method where the model makes prediction without seeing examples of the tasks during training. So what we are doing here, we are going to train a model in a way that makes prediction without seeing examples of the task during training. So we are going to perform this particular part and we can see the results here. Okay, similar results. This is the input prompt. We have everything here. This is the summary and this is the model generation. Zero shot, how long it is. So we are going perfect. So zero shot interference with the prompt templates from Flan T5 actually help us in exploring. So further exploration to zero shot interference, this time using a prompt template, let's say specific for Flan T5. Okay, so let's say this is the prompt, this is the dialogue, what was going on, and then we have same thing happening here, and then we have everything happening. Cool. So this is the result we get. Similar, Tom is going to the railway station according to the dialogue that we have already given it. So we are going correct. Now summarizing dialogue with one shot and few shot interference. So one shot and few shot are the practice of providing an LM model with either one or four full examples of prompt response pairs that match your task, but before your actual prompt that you want. So this is called in context learning and puts your model into a state that understands your specific task. So you can, so yeah, I will just mention that blog link in the description section where you can actually read about this. Now similar thing with one shot, we are going to we will build a function that takes a list of examples, generate a prompt with full summaries, then at the end do everything. So yeah, we will do this and we are going to use it again. So what was going on, same thing is happening here, but you can see the difference here clearly. The difference is very clear, and we will construct the prompt to perform one shot interference. So you can see what was going on and everything is happening here. The dialogue is given and then you get the result, what was going on. Now we are going to pass this prompt to perform the one shot interference. So we are done with the prompt, we have created it. So this is the prompt, we are taking the summary part, this is the input, the one shot prompt format that we are following, the return is PD, and then we are going to get output. So this is the part, this is the actual thing that we are passing. Where did it go? Yeah, this is the baseline human summary that person one teaches this what expect from the software. Okay, what does model do? Model 2 is sort of giving person one is saying I'm not sure what to expect from a software. This was the overall summary. Now when it comes to few shot interference, same thing is happening. We will explore few shot interference by adding 2 more dialogues. Okay, same thing is happening here. Similar thing, just 2 more dialogues added, nothing something fancy. And similarly it's longer, so running the sequence to the model, you can ignore this for now, and this is the result that we get. Now we have to generate configuration. So let's summarize with one flow. So one shot interference, the model is giving a single example and it's expected to generalize from it. In the few shot interference, the model is provided with a few examples before making predictions, and Now we are going to talk about generative configuration parameters for the interference. So we can change a lot of configuration patterns of the generate method that we were using above to see different outputs from the LLM. So far for the only parameter that you have been seeing was max new tokens was 50. A convenient way of organizing the configuration parameters is to use generation configuration class. Cool. We are going to use this. You see here. So you can do anything here actually, to be honest. You can just uncomment it and comment it and then try your things. Now I'm going to tell everything in detail, like what is happening. If I just simply go, I want to do something fancy, just like a student, I will simply go and type it. Okay, now I want you to just go in flow with me. All the parameters that you see here are very effective when it comes to prompt and everything. So here you can see all the things. When it comes to max new tokens, the maximum number of tokens to generate, ignoring the number of tokens in the prompt. It was very clear. I told you in the beginning. What does do sample and temperature do here? Cool. So whether or not to use the sampling, using, we will use greedy decoding. Otherwise, if we don't use this, it usually it's default set to false. But if you want to do that, you set that to true. Now when it comes to temperature, the value used to modelize the next probability token. If I don't do this and go with 0.2, maybe something result would be different. So person I like to propagate my system. This is the model generation and baseline humor summary is something different. Now if I do this 0.2, maybe the results would be different. I would like you guys to go and just check this once out. Okay, I just ran one code above and it's still not, so I think there's some glitch in the notebook, but not a problem. So I just want you guys to experiment with this and just learn the basics, how actually things are working here. So yeah, that was it from my side for this particular video. I will provide the link to the notebook and everything in the comment or description section as usual, and you can go and learn from there. So thank you and have a nice day.